So to all of you, and today we are going to discuss Grignard reaction. Okay, so Grignard reaction, we will only discuss the preparation of triphenyl methanol. Okay, so how you can prepare in the lab easily triphenyl methanol. Okay, so if you see in the M.Sc lab, either you can see from B.Sc, M.Sc as well as other research courses, in practical there are lots of Grignard reactions are carried out. Okay, but in this we only discuss the preparation of triphenyl methanol. Okay, so first of all, see the background. Okay, so Grignard reagent, all of you know that it is highly reactive organometallic reagent. Okay, and it is generated by the treating alkyl or allyl halide with magnesium metal in the presence of anhydrous ether. Okay, so three reagent is taken here. One is alkyl or allyl halides and magnesium metals. Okay, so one reagent is required alkyl halide or aryl halide. Second one is metal is required, and third one is anhydrous ether, which acts as a solvent here. Okay, so one reagent, one metal as well as ether is required, which acts as a solvent here. Okay, so in Grignard reagent you should be focused first of all that how much entities are present or how much types of molecules are present. Okay, and molecule may be either reagent or you can say magnesium metals or and solvent. Okay, so in this only alkyl aryl halides, magnesium metal and anhydrous ether is are present. Okay, the reaction proceeds like a strong base reactions. Okay, so it looks like a strong base reaction, you can say. Okay, so first of all, what happened here? You will take RX, alkyl halide or aryl halides, and some amount of metal is added in the alkyl halide, alkyl as well as aryl halide. Any one you can take. So it forming the RX. Okay. After that, what happened here? It looks like minus charge, means it acts as a base here. Okay, all of you know that metals act as a metals, magnesium act as a metal. Okay, and and metals carries the positive charge. Okay, so complex will be formed here, means RMGX will form in which magnesium feels positive as well as alkyl halide feels the negative charge. Okay, so this region was discovered by Vector Grignard around 1900. Okay, so okay, so it is the basic reactions and their discoverer. Okay, and you should be know about the regarding the reagents, how you what entities are present in the Grignard reagent. Okay, so it is the slide. Okay, if you have any queries regarding this slide, you can write down your comment in the comment box. I will solve your queries. Okay, so come on the second slide. In this slide, I have also mentioned some properties of Grignard reagent. Okay, so Grignard reagent, all of you know that it is made up of our alkyl, means three entities are present. One is alkyl moiety, magnesium as well as halide. Okay, so it is capable of reacting with many different substrate. Okay, different substrate which means this R which acts as a base character, which has basic character, you can say, or you can say that it carries the negative charge. Okay, so negative will act on the electron deficient side, and in this you can take any electron deficient side as well as ketone or aldehyde like that. Okay, so here the reaction is carried out with ketonic moiety. Okay, so such as carbonyl compound reacting with different substrates such as carbonyl compound. So this is the carbonyl compound, or you can reaction is carried out with alkyl halide or other organometallic reagents. Okay, so so it is the means you can carry out the reaction with different types of different types of substrates. Okay, the addition of Grignard reagent to carbonyl compounds such as aldehyde, ketone, or ester yield the corresponding secondary or tertiary alcohol. Okay, so you can see here means there are lots of ketonic moiety, means containing compounds are present. Either you can purchase industrially or you can prepare in the lab. Okay, so it may be either aldehyde, ketones, or ester. Okay, this yields the corresponding secondary or tertiary alcohol. How you can means how this happens. Okay, so it is the remarkable question here. Okay, so first of all, R will attack on the CO. Okay, so charge will be this 2 electron of CO will transfer to the oxygen. Okay, and mgx will be free because R minus has been replaced here. Okay, so mgx O minus charge means negative charge will capture the mgx. Okay, forming this salt-like structure. Okay, and after that you hydronia means what? If you add the water, it forming the secondary alcohol. Okay, so this is the final product. Okay, so it is the application of Grignard agents. Okay, So okay, so the Grignard reagent is results in the formation of carbon-carbon bond. Okay, so if you want to prepare any carbon-carbon bond in, so you can take the Grignard reactions. Okay, and the next one is Grignard reagents are extremely strong base. Okay, so it acts like a strong base that can react violently with hydroxylic compounds such as water alcohols. Okay, Grignard reaction result in the formation of carbon-carbon bond. Okay, so if you want to make any carbon-carbon means if you want to combine two molecules and so with carbon-carbon bond, then you can proceed the Grignard reaction. Okay, Grignard reaction are extremely strong base. Okay, why it is called a strong base? Because R act as a base here. Okay, R minus into T acts as a base here that can react violently with hydroxyl compounds such as water or alcohol. Okay, so it is an extremely strong base. Why it acts as a strong base? Because R minus will be generated from this one. Okay, which attaches from the electron deficient, or you can say electropositive elements, electropositive atoms. Okay, so R will capture the hydrogen forming the RH, as well as remaining species will be the Mg OSBr or OH MgBr. Okay, so it is the other means other entity or side products, you can say. Okay, so next one is experimental techniques. Okay, so experimental techniques means in the lab how you can proceed. Okay, so in the laboratory, initiation of Grignard reaction is sometimes very slow. Means Grignard reaction is very slow. It is not very fast reaction. So because of the presence of air, a coating of magnesium oxide from the magnesium metal turnings. Because what happened here, reactivity why it is low? Because in metal react with the air. Okay, so it forming the coating of magnesium oxide. So that's why reactivity will be become, or you can say become less. Okay. To initiate the reaction, adding a small crystal of iodine or drop of dibromoethane can help to clean the surface of magnesium. So before starting your setup, or before starting your reactions, first of all you should add the small crystal of iodine. Okay, or you can, or a drop of dibromoethane, which help to clean the surface of magnesium. Okay, so first of all, cleaning is very necessary before processing the experimental process. Okay, today's experiment is preparation of triphenylmethanol using a Grignard reagent. Okay, so how preparation of triphenyl method using a Grignard. So it is the actually the main it is the main purpose for to prepare the triphenylmethanol. Okay, by using the Grignard reagent. Okay, so first of all, bromobenzene is this one, magnesium is this one, and ether act as a solvent here. So one metal is required, bromobenzene is required, it forming the phenyl magnesium bromide. Okay. Second one, how other species is required means you will require the triphenyl methanol. Okay, it is the product. So your starting material will be the which this is the first of all phenyl magnesium bromide is required. Second one is the acetophenone is required. Okay, COOCS3. Okay, so it's forming the it is the trimer. Okay, thrice COMgR will be formed, and in the presence of H2SO4 it forming the CHO. Okay, so the next step what happened here, first of all MgBr2 2 ether will be formed, and second one it will react means the R, this is the aromatic moiety. Okay, so it acts as a base here. Okay, so it will act on the CO means electron deficient side forming the O minus. Okay, so so by this process this forming the MgBrO minus, Mg containing the positive charge here. Okay, so after that what happened here? Okay, so this is the CO. Okay, and this is the dimer. So dimer, if you see here, so it looks like that. Okay, the remaining will be, this is the OCS3 Br Mg, it is the other living group, you can say. So it is the Br Mg OCS3. Okay, next one what happened is other Grignard reagent will reaction will be occur by the other Grignard reagent on the CO, because it is the electron deficient. It is the dimer, so only one phenyl is required for forming the triphenyl. Okay, so looks like that. You can see the final products. This is the triphenyl, which is the O minus MgBr. Okay, so O containing the negative charge, Mg plus Br containing the positive charge. Okay, so by this one, this is the actually final your desired product. Okay, but it is the O minus MgR. So O Mg, this bond required to break. Okay, so you add water with forming the hydronium ion, and it forming O minus capturing the hydrogen, forming the this is the okay. So when not this one, when MgBr will be released out, O minus means this bond will be shifted to CO, means it forming the this one. You can see this one, this is the O minus when you will add S3O. So because it cannot convert to CO because valency is much more. Okay, it will be the 5, so it will not your product. So that's why O minus capturing the hydrogen from this one, converting the OH. Okay, so this is the final product. Okay, and it is the your target product, you can say. So water sensitive chemical reaction required throughoutly dried glassware. Okay, so before operating this Grignard agent, what is required? First of all, you will require the dried glasswares. Okay, no visible water. There will be no visible, any moiety will be not present in your experiment. Okay, rigorously dried and hazard grade reagents, heat gun dried glassware required, means eliminate invisible water. Okay, so dried glassware, heat gun is required for drying the glassware. You can easily dry by using the heat gun, because if you put the glassware in the oven, so time taken will be the more by that process. Okay, a drying tube packed with a dry agent CaCl2 and nitrogen argon line supplying drying in that atmosphere. Okay, okay, so it is the nitrogen or argons. This is the some gases which maintain the inert atmosphere. Okay, experimental procedure. If you see this one, no washing glassware with water today. When you will operate the Grignard reaction, so you never use the water. Okay, use acetone if you require, because it is boiling point is less as compared to water, so it is easily removed. Okay, by using heat gunner like that. Ether is extremely flammable. Okay, ether is extremely flammable. Okay, so there will be precautions is required. There will precautions is required by when you will use the ether. Okay, adequately greases are all joints to avoid leakage of fumes. Okay, so if you are operating the Grignard agent, all the joint require the adequate greases. Okay, so you will use the grease. Okay, leaking, which will avoid the leakage of fumes. Okay, usually fresh or new diethylator. So if you want to if you want to if you are going to operate the Grignard agent, so that day you will distill the diethylator, which will be dry. Okay, otherwise if you use means if you use previous diethylator, okay, so it will not good for you. Okay, the boiling point of diethylator is 35 degrees Celsius. Okay, and so do not set max setting for the temperature controller. So diethylator is boiling point is very low, 35 degrees Celsius. So there will be temperature much more is not required, because boiling point is late. So mainly Grignard reagents carried out in at very low temperature, and it is -70. Okay, -20, -70. You can 0 to -70. You can use this temperature by using different types of methods. Methods are means used, such as dry ice or other extra. Okay, so dry your 10 ml gauge cylinder and 100 ml alien flask with heat gun before any use, tightly covered with aluminum foil. Okay, so before operating this experiment, there will be required to heat, required to dried glasswares. Okay, so you will easily by using heat gun you can dry that process. Okay, so remove the magnesium oxide from magnesium metal surface using mortar or pestle. Okay, so this one like that. Okay, so this is the equipment setup. How? Okay, so it looks like that. Okay, so no boiling chips with magnesium. You will never use the boiling chips. Okay, assemble as shown on the right, except need to add dry tubes. Your TA will show you how to assemble the drying tubes with CaCl2 as the drying agents. Okay, so CaCl2 it acts as a dehydrating agent. So you can use this one. Okay, use warm water about 40 degrees Celsius as heat source using the large beaker. Place the bath at wire base to top up the heating mantle. Monitor the temperature during reactions. So for monitoring the reactions, if you carried out -70, so there will be what you will do, you will do the thermometer. Okay, so your setup, you will initially you will set up the temperature on that medium. Okay, so by which you can see easily the temperature, means what is the temperature of the inner atmosphere. Okay, do aluminum foil. You will never use aluminum foil for this setup. Okay, okay, so in mostly what happen here in do not use the hot plate, because this type of reaction is carried out in low temperature. Okay, so this one. Okay, so next one, what happened here, so there will be some reagent is required. First one is bromobenzene. Next one is what is required? Grignard agent. Heat gun is required. Okay, and you will count the equivalent. How equivalent you will use the bromobenzene, and how equivalent you will use the Grignard agent. So in this type of metrology, always use the 0.2 or 3, much more equivalent Grignard agent. Okay. Okay, and mainly water is used for the final step for breaking the O minus Mg Mg like that mighty. So on this step you can use the ammonium solution. Okay, you will use the water and plus ammonium salt. Okay, So this one, okay. So you will use the 3-5 drops of dimethane in a couple of crystal of iodine, okay. So actually this is the round bottom plus in the bottom, and in this what happened here, you will use first of all you will put the ether, okay. If you carried out 500 mg reactions, okay, so 500 mg is required. Bromo means what is required? This required bromomethane, dibromo, not this one. This there will be requirement of bromobenzene. So 500 mg. First of all, you will use the solvent. Means 100 ml solvent you will use. For 100 mg, you will need, there is a 50 maximum 50 ml you will require solvent, but it will be dry. Okay, so add first of all solvent will be added. After that, bromobenzene will be added. Then you will use the what Grignard agent. Okay, drop wise you will use. Okay, okay, and temperature will be maintained here. Okay, so actually the final step in which you will this step is called quenching. Okay, so prepare 25 crystal ice, 50 ml 10 H2SO4. You can use 10% H2SO4. Add them into a layer flask. When you will finish the reflection the reaction mixture, 30 minutes, pour the into the layer flask, or you can also use the ammonium chloride solution in water. Okay, so it is the Grignard reactions. Okay, so after Grignard reaction, what happened here? The product will be formed and it will be checked by the TLC. Okay, all of you know regarding the TLC. So when your product will be formed, reaction will be you should be stop your reactions, and product will be separated by means using the what separating funnel, and add your products, and into it organic solvent is used. Okay, and after that what happens, some water will be added here. So water will be comes in the bottom, as well as your product will be comes in the organic layer. Okay, so easily you can separate this one. Okay, so it is the your synthesis and separation of which your targeted product means this is that your target products triphenylmethanol. Okay, so if you like this video, please like, and if you have any queries regarding this, okay, if you are going to help this type of reactions, and if you have any queries regarding this, then please write down your comment box in the comment line. Okay, I will solve your problem experimentally, not theoretically. Okay, so thanks for this.